So let's talk a little bit about basic properties of electrical circuits. Start with voltage. So we got our circuit on the left side of the screen rather, and the circuit in this case has got a battery on the left. On the right, it's got that squiggly line there. It's called a resistor, and we'll talk about that in a few slides. But a resistor basically provides resistance to the current flow. So that could be a number of things, and we'll talk about that in a couple of slides. But that's our circuit, and current is flowing from the positive through that resistor to the negative. Now, on the other side, over there, next to it, we have the water, the analogous water circuit. Now, the water, it's they got a pump, it's pushing water. And notice that I put some rocks inside the pipe, right? So these rocks are providing resistance to the water flow. So there, I'm going to call those resistors. Those are similar to the resistors inside the resistor inside the electrical circuit. So this concept of voltage. Voltage is called the potential difference between 2 points in the circuit. So what this means, potential difference is think of voltage as the pressure. So voltage is just like the pressure in the water system. That pump provides pressure on the water that you can measure with, say, a pressure gauge, right? But note that the pressure is what actually pushes the water through, right? So voltage, that battery in our picture, is actually providing some voltage, providing that essentially the pressure on the carriers, on the electrons, to push them through the circuit. So think of voltage like that. Now note that pressure difference is what counts. So what I mean is there's pressure, but current only flows if there's a difference in voltage, or like in water. Let's take water, to start with water. Let's say you got a pipe. This pipe, two ends of the pipe, right? And there's water flowing through, but there's two ends of the pipe. And both of them there's a high pressure you put a powerful pump on one end, right? So there's high pressure there. You put a powerful pump on the other end, same pressure. So there's high pressure on the other end. How much current is flowing? If they're equal pumps with equal pressure, then there's no current flowing. Even though you've got high pressure on one end, high pressure on the other, the pressure difference between the 2 points, between the two end points of the pipe, there's no difference in their pressure. So there's no flow. Right? So even though there's high pressure, the pressure difference is what counts. And voltage is the same way. There has to be a difference in voltage, and that's a difference in what they call potential difference in potential. So between the positive and negative terminals of the battery, you have a potential difference of whatever amount of voltage the battery is. So say that battery is rated at 5 volts, then that means there's 5 volts potential difference between the positive and negative terminals, which means that if you wire those two together, current will flow from the positive to the negative. So it's measured in volts. And note that I should note that the voltage on a particular, anything that is connected by a wire, like just a plain wire, perfectly conductive wire, they have the same voltage, right? If there's no resistance in between. Of course, in our circuit, we have resistance in between. Okay, so that's voltage. Current, another important property of a circuit. Current is what you think of it as. It's the rate at which the carrier flows past a point in the circuit. Okay? So if you look at the water, the rate at which water is flowing past a point in the circuit, you call that the current flow, the current rate. And you get the same thing in our electrical circuit. Now, current flows from positive to negative. That is the standard, that is what people say. Now, that's not exactly what happens. So remember that in current, with electrical current, our carriers are actually electrons, right? And now, we don't need to know this for the class, but I should throw this in because sometimes it's confusing. But understand that electrons are negatively charged carriers, right? So they don't actually flow from positive to negative. They flow from negative to positive, okay? So even though we say that current flows from positive to negative, in reality, the electrons are flowing from negative to positive, okay? Just be aware of that. But still, when people talk about current flow, they always say, oh, it's going from positive to negative. So always think of it that way. I just wanted to mention this to you because sometimes if you know anything about electrons, then you know that it can be a contradiction in your head. So that's there, but just understand everybody says positive to negative current flow. Okay, they're talking about the holes. The lack of electrons is moving from positive to negative. You can think of it like that. It's measured in amperes or amps. So 1 amp is a unit of current. All right, resistance. So resistance is basically any obstacle to current flow. So in terms of our water system, I put some rocks in the pipe, and that's a resistor effectively. It's providing resistance. It's slowing the water flow and reducing the rate, right? So that's resistance. There are a lot of resistors you could put in there. You could put a sponge in there, right? And that would, water could flow past it, but it was hard to flow past it. So that's a resistor. Now for us, in an electrical circuit, So water, for water, just a rock or a narrow pipe, if you make the pipe narrow, that adds resistance, right? It's harder to push through, pump through a very narrow pipe as compared to a big wide pipe. So for water, that could be the case. For a circuit, it's basically a bad conductor, okay? A suboptimal conductor. So if you just have pure copper wire, there's very little resistance in there. It's very good for conducting. But if you use some other material that doesn't conduct as well, then it has a certain level of resistance. Now then you can go to an extreme and use an insulator is just something with extremely high resistance, like the air, right? Regular air at regular humidity levels, it's an insulator, right? It has a very high resistance between any 2 points in the air. So, but there's a gradation, right? You can have different types of materials that have different levels of resistance per unit length. Also, a narrow conductor, the narrower the conductor is, the more resistance it is. So if you take a wire, you have a big fat wire, that's less resistance than if you have a really thin wire. And actually, this is important with high power electronics. You have to use big fat wires because there's so much current, the resistance will produce a lot of heat. So you need big wires to drive a lot of current, or else you'll get too much resistance. So that's what resistance is. So we've got voltage, current, and resistance as our simple, ideas and principles that different aspects of electrical circuits that we need to be aware of a little bit. And resistance is measured in ohms. Thank you.